Chapati, working as assistant professor in Mechanical Engineering Department, Institute of Technology, Nirma University. Now, today we are going to discuss a topic that is projection of points and lines. So, first of all, let's try to understand what is the projection. So, as per the definition, projection is to locate different points of the object on a reference plane. So, here two terms are very important: object, whose projection we want, and the second, that is the reference plane. So let's try to understand this concept with the help of image. Here, if you just see, one cuboid is given in terms of body. Here one observer is there who is observing the object, and on a back side of our object we have one reference plane on which we want to shift uh, points of an object. So now here, if you compare this case with a shadow, when shadow is appear on a wall, when we throw a light with the help of torch. Suppose torch is over here, here the object is there. Now if you throw a light, then these are the four corner points which resist the light, and as you throw it on a this vertical plane, then you get a shadow over here, which is nothing but a view of an object. It's a outer line of an object, and on a background you will get a illumination. So this is nothing but a projection system. Projection, that means shifting the point of an object on one reference plane. Now again, various type of projection systems are there: orthographic projection, oblique projection, and perspective projection. Now what is shown over here in this figure, that is nothing but an orthographic projection. Why orthographic projection? Because here we assume that the observer that is having infinite distance away from a body and from a vertical plane. So and so it is possible to get a projector. These dotted lines are nothing but a projector. So here in orthographic projection, we assume that observer is far distance away from object. Then we can get all the projectors are parallel to each other, and these projectors are perpendicular to a reference plane. So that's why it is called as an orthographic projection system. So in normally we follow orthographic projection system when we are dealing with true shapes of any object or true views of any object. Now in this orthographic projection, again three components are very important. The first component, that is the object whose view we want. Second, that is the observer, means from which direction observer viewing the object. And the third one, that is the reference plane, on which plane we want the projection. Now let's discuss about the reference plane. What is the reference plane? Reference plane is a plane on which we project our view. So as if we are dealing with only two views, front view and top view, then two reference planes are there. First reference plane, that is the horizontal reference plane. So the plane which is parallel to Earth's surface, that is called as a horizontal reference plane. The second one, that is the vertical plane, vertical reference plane, means plane which is perpendicular to horizontal reference plane, that is called as a vertical reference plane. Now to get a good idea about these two planes, if you assume a room of a home in which the floor, that is work as a horizontal reference plane, and the walls of a room, they are work as a vertical reference plane. So both are mutually perpendicular to each other. Let's consider here, this one is a horizontal reference plane, and a second plane, that is vertical reference plane, which is perpendicular to horizontal reference plane. As if we arrange these two reference plane perpendicular to each other, we get a common intersecting line, this xy, which is called as an axis. And now if we arrange these two reference planes in this way, then we get four different quadrants. If object that is above HP and in front of VP, that means that is in first quadrant. If object above HP behind VP, then that is called as a second quadrant. If object below HP and behind VP, then that is called as a third quadrant. And if object below HP in front of VP, then that is called as a fourth quadrant. That is called as a in fourth quadrant. So we can place object in any one quadrant if we are dealing with a point and line only. But if we are going for projection of a solid object, then it is convenient to use only first angle projection system and third angle projection system. Now suppose observer is observing the object from a front direction. Somewhere in between the observer and vertical reference plane, you have an object somewhere over here. Then after viewing that object, we project the points of object on a VP. Then the view which is available, that is called as a front view. Same way, if observer viewing from a top, and if object is in first quadrant, that means it is in between observer and the horizontal reference plane, then you get a view which is called as a top view, and it is on horizontal reference plane. Now if we see this quadrant system from a side view, then this VP is a one reference plane which is look like a line. Then same way, this horizontal reference plane, again it is a plane, so it is look like a line, but both are perpendicular to each other. And this XY line is look like only a dot. So now first quadrant, this one is a VP, this one is a HP, and the first quadrant, that means above HP, here we have observer. Now the first quadrant, that means above HP in front of VP. Second quadrant, that means above HP behind VP. Third quadrant, that means below HP behind VP. And fourth quadrant, that means below HP in front of VP. Now suppose if we have got both the view, front view and top view, then the next important thing is how to draw both the view in a single paper, because here we have a two-dimensional drawing, and here in top view again we have a two-dimensional drawing. That means if we want to draw these two views, then we need to make a single plane, means both the drawing in a same plane. Then the regular practice as per the standard is to, after getting the top view, rotate this horizontal plane by clockwise 90 degree, then that would be a vertical plane. Then you can draw both front view and top view in a, you can represent both the view, front view and top view, in a same VP. Then the second important thing is for front view, if you are drawing the front view, then the vertical reference plane, that is work as a reference plane for you to get a view on it. At the same time, this horizontal plane that overlaps on XY. So XY is considered as a HP when you are dealing with a front view. Same way, the second concept is for top view, XY line is a vertical plane, because as the observer viewing from a top, this vertical plane that overlaps on XY. So for top view, XY line is work as a VP. These are the three concepts which are required for the projection system and to get a different view. This is all about the object when it is in first quadrant. Now let's discuss the project. Okay, the next thing is how to recognize quadrant. That is already we have discussed. The first quadrant, that means above HP in front of VP. Second quadrant, that means if object that is above HP and behind VP. If third quadrant, that means if object that is below HP and behind VP. And fourth quadrant, if object below HP and in front of VP. This is how to recognize the quadrant in which our object exists. Then terms above and below with respect to HP, and terms in front and behind with respect to VP. Now the notation. Notation is very important, because normally when we are dealing with front view and top view, means different orthographic views, we identify a view based on their notation. So here let's discuss about the notation. Suppose object, there are two objects. One is a point A and second one is a line with two ends, capital A and capital B. Suppose if you are drawing a top view, then notation for top view of object A, that is small a, and notation for object line AB is small a and small b. Same way, if you are drawing the front view, then notation for point A, that is A dash, and notation for line capital A capital B, that is A dash and B dash. If you are drawing side view, then to notate a side view we use A double dash, and for line we use A double dash B double dash. So the common understanding is notation for top view, that is small letters without dash, and notation for front view, that is small letter with dash, and for side view small letter with double dash. Same notation system is also applicable for numeric value. If you are using numbers 1, 2, 3 for front view, top view and side view, then 1 without dash, that is for top view, 1 with dash, that is for front view, and 1 with double dash, that is for side view. Okay, now let's take a different cases when point exists in all 4 quadrants one by one. So let's take a case when point A is above HP and in front of VP. So as the observer viewing the object from front, then projection of capital A perpendicular to reference plane VP, that project on VP somewhere here. So front view that give you distance with respect to HP, that is A dash, means what is the place of point A above HP, that is visible in front view. Same way, if observer looking the object from top, then this projector, this one is an orthographic projection, this one is called as a projector. So this point A, that is projected on horizontal reference plane, and notation is small a. Now this top view that shows the distance of point A with respect to VP, means what is the location of point A in front from VP. Now as the common practice, suppose if you want to show front view and top view of this point A on a same paper, then as per the tradition we need to rotate this reference plane in clockwise direction by 90 degree. Then whatever the distance of this point in top view from VP, that would be the distance of point from XY. Here we have XY, from XY below, same distance. Then the notation, that is A, and both lie on a same line, A dash and A. Now take a second case when point that is in second quadrant. So for second quadrant, point that is above HP, point A that is above HP and behind VP. Now if observer observing from a same location from a front view, at that time we assume this vertical reference plane as a transparent. So we get a back projector for a front view over here. And the notation for front view, that is A dash. Again I am repeating, front view that shows the location of point A from HP. Now after that, if observer moves towards the top and view the object, then at that time horizontal plane is work as a reference plane and projector shift over here. And as per the tradition, we need to rotate, after getting top view, we need to rotate this horizontal reference plane by 90 degree clockwise such that it align with VP. So after rotation, this point A, which having a distance with respect to VP by some distance, that same distance that will be now above XY line, and here the notation is A. That means if point that is in second quadrant, then front view and top view both exist above XY line, because here at a common intersection here we have a XY line, so they both reached above XY line. Now same way, let's take a third case when point that is below HP and behind VP. See this point A that is below HP and behind VP. So here again observer observing object from front view. So again we assume here VP as a transparent plane. Then we get a back projector on VP. So distance of point A from HP, that is visible in front view, but now the front view that is below XY line by a same distance as the distance of point A from HP. Now same way, if observer moves toward top and if view the object A, But now again here also we need to assume HP as a